Okay, so here they're asking for the efficiency, right? What is the base equation for efficiency? If I give Calvin some cash and I tell him, go invest this, I'm going to rate you on your efficiency. When he comes back, how do I calculate his efficiency? Yeah, I calculate the amount of money he brought back over the amount of money I gave him, right? And then that's going to, so in general, do you remember when we were talking, what is a steam engine? The steam engine in a ship is, or the combustion engine in your car, those are classically called what? Well, careful, they're called heat engines, right? This is a heat engine. What is the difference between an engine and a pump? Say that again, Stefan?
An engine is more than just a pump. It has pumps and other stuff.
Okay, so an engine does more than a pump. That's true. What does an engine do? Sarah? Okay, it combusts, so it has some combustion. What's the point?
Energy.
Take energy and turn it into what? Okay, it's going to get turned into heat, which gets converted into, like, do you put gas in your car so that you can stay warm? Why do you put it?
Why?
Devin's like, yeah. I hate being cold. Why do you put gas in your car?
So you can turn the wheels.
So you can go somewhere, right? You want work. The difference, please note this, the difference between a heat pump and a heat engine, a heat pump just moves heat. A heat engine turns heat into work. Heat pumps just move heat. What does a water pump do? Yeah, it moves water, pumps water. So what does a heat pump do?
Pumps heat.
It pumps heat. Okay, so the heat engine, everybody here clear on the difference between heat pump and heat engine? And you must know how they both work. Heat pump, I went over it at length yesterday. Heat engine, we just learned from Calvin, obviously, that it's going to be this. Because remember, a heat engine takes hot and then cold and turns it into work. Okay? Now, what is work based on, like this? Based on this, can you come up with an equation that relates QH, QC, and W? At your table, come up with an equation. Amy's group, what'd you get?
Work is QH minus QC.
Nice. Does that make sense? I mean, obviously, you could just look at this. What goes into the system? QH. What does that become? Right? Do you see this? And then, okay, these statements are mathematically identical, yes? So, up here, I write QH minus QC over QH. And do I have QH and do I have QC? Yeah, of course. They're given. Well, okay, let's what we can do is we can do this. If I take this and work on this equation, do you see that I get 1 minus QC over QH? Does that make sense to everyone? Okay, now walk with me here. What is Q? MC delta T, right? MC delta T, right? What's true about these masses? Same. What's true about those specific heats? Same. So what we actually get, is TC over TH. And do we have TC and TH? Absolutely. This is TH, this is TC. So now calculate the efficiency. right? It's going to be 1 minus 273 over 523. So it's about twice, right? So it's going to be a little less than 1/2, right? Okay, so we get 0.474 or 47.4% efficient. Actually, steam engines are much more efficient than cars. Combustion engines. It's just a combustion engine has a much higher rate of oscillation, of detonation, so you can get more power in a smaller amount of time. Yeah, but up until our president decided to make gas $4 a gallon, it wasn't a big deal. It could be worse. In Europe, it's $6 a gallon.
Wait, so 47.4. What's that?
That's the efficiency. So if you put in, I don't know, a log that's 10,000 joules of potential energy, then you will get out 4,740 joules of work. That's what that means. Yeah.
How'd you get that MCW?
Well, what's Q?
MCW.
Yeah.